Okay, so we're going to be presenting HeartHelper, which is a data analysis project that's focused on heart disease. So heart disease is the world's leading cause of death, so we were really interested in seeing what factors related to it and how it affected different groups of people. So just for some background on our project, we used a data set that was collected from the 2015 Behavioral Risk Factor Surveillance System, which is a phone survey that's run each year by the Centers for Disease Control. And based off of that data, we created 3 machine learning models. The ultimate purpose of our models was to predict whether an individual is at risk for heart disease or a heart attack based on several variables that the user reports describing their personal lifestyle and like health habits, their past medical history, and their demographics. And some of our hypotheses going into this was that heart disease prevalence would be especially high among lower income groups and older age groups. So we ended up using 11 variables for our models after doing some initial data analysis that we found were strongly linked to heart disease and heart attacks. So the variables we focused on were age, blood pressure, cholesterol level, whether the person smokes, if they have a history of stroke, their sex, their difficulty walking, a general report of their health, like how they would describe their health, whether they had a cholesterol check in the past 5 years, if they have diabetes, and then their income bracket. So to start off, this is how we explored the data set to see like which variables we might want to focus on when predicting heart disease. So first, we looked at the prevalence of heart attacks by age groups. So you can kind of see as age increases, there's a pretty consistent trend that shows that the percentage of people with heart disease and heart attacks is also increasing, which supported our hypothesis. And also a lot of like existing scientific data shows that people in older age groups are more susceptible to heart disease. So our analysis was supported by pre-existing data. We also looked, similarly, we looked at the prevalence of heart attack and heart disease by income group. So this one also shows how, like, according to your income bracket, how the percentage within each group that has heart disease changes. So you can see as income increases, the prevalence of heart disease and heart attacks generally decreases, which makes a lot of sense. The highest income group has the fewest instances of heart disease and heart attack, which supported our initial hypothesis. And we thought this might be because income is very heavily related to your ability to access good quality healthcare, to receive like the medication you need and get a diagnosis in time, and also just to have the resources to build a lifestyle that's healthy for your heart. Finally, we looked at the count of people with heart disease by smoker status. So these graphs show the counts of people who smoke and don't smoke, and then the number within each of those groups who has heart disease or a heart attack. And even though this graph doesn't show proportions, you can kind of infer this is about 16% of smokers, and this is about only 7% of non-smokers that reported heart disease or heart attacks. So there's a pretty big difference there. And since data shows that smoking tobacco products is heavily correlated with heart disease, this finding is also supported by existing data.
All right, so for machine learning, we used 3 models to determine whether someone had heart disease or not. And our first model was a k-nearest neighbors model. And this is a classification algorithm that predicts the class of a data point based on its proximity to neighboring data points. And it calculates a distance between the new data point and a specified number of training data points. And this is used to label the new data set. And our accuracy for this model was 75%, the precision was 73%, the recall was 78%, and the F1 score was 76. And a high precision score means there aren't many false positives, while a high recall score shows there isn't many false negatives. And at first, when we did this model, we had a very high accuracy, but very low precision and recall scores. And this was because the data set we trained this on had like 90% of the people had no heart disease. So the model would always guess they didn't have heart disease. And so they would have a 90% accuracy, even though they're just guessing no heart disease every time. So to fix that, we made a new data set that had equal amounts of people who had heart disease and no heart disease. And this made the accuracy and precision scores like a lot closer. So the model was actually trying to figure out whether they actually had heart disease, not just guessing the same thing over and over again. Also, you can see on the right side, we have the confusion matrix, which just shows like the predicted versus actual heart disease. Okay, so for our next model, we use a logistic regression. And this basically just makes a logistic function and sees how the new data relates to the function, and then it guesses and classifies based on the function. So this accuracy was a bit higher, and the precision, recall, and F1 scores were a little bit higher too. And then our last model was a random forest model. And the random forest model is basically a lot of decision trees put together. And decision trees use if statements to make a prediction. So the random forest makes each decision tree independently make their own prediction, and then just averages or sees which label has the highest amount to make the final prediction. And the accuracy is about the same as the logistic regression, but the recall and F1 score are a bit higher.
In conclusion, the random forest model showed the most accurate performance overall. This model also had the lowest percentage of false negatives and the highest recall score, an important factor to consider for medical diagnosis. The model was likely more accurate because multiple decision trees allowed for an in-depth search of the data that returned the most common outcome from several different data subsets. Being able to use data about medical history or personal characteristics to predict heart disease/heart attack risk can help patients obtain necessary treatment ahead of time. It provides valuable insight for those who are unable to access or visit a doctor. And then we also made a gradient model, which includes all 11 variables, which was previously mentioned. And once you put all the variables in, it predicts whether you have heart disease or not, as you can see. You can see here it says negative. And we used our random forest joblib model in this Gradio to get our predictions, and some roadblocks while making this Gradio actually were that the predictions would at first the predictions would only say 1 or 0, 1 being positive and 0 being negative. And to fix that, we used an if and else statement. And another problem we had was for the yes or no questions, we would have to use info. And under, as you can see, it says, do you have high blood pressure? 1 is yes, 0 is no, as the data set use 1s and 0s as yes or no. And that is all.
Yeah, and so this is our team, and thank you for listening.